afternoon, class.
Good afternoon, Mrs. Hui.
Thank you. You can sit down. Right, in today's lesson, we'll continue with matrices. You are asked to take some notes from your textbook on that topic. And today we'll look at adding, subtracting, and multiplying matrices. All right, but before we do that, we'll have to do a bit of review on what we have looked at so far. So, we looked at the types of matrices in our previous lesson. So you have to define the following. Number one, what is a row matrix? We'll start from Solomon. Tell us what a row matrix is.
A row matrix is a matrix having only one row.
Okay, it's a matrix having only one row. Okay, number two, Andrew, what is a column matrix?
A matrix having only one column.
Okay, it's a column matrix having only, a column matrix is a matrix having only one column. Number three, what is a null matrix? Daniel?
A matrix with all its elements 0.
All its elements are 0. Gabriel, number four, you have to tell us what the fourth type of matrix is and define it.
The fourth matrix is a square matrix. This is a matrix having the same number of rows and columns.
Okay, good. It's a matrix having the same number of rows and columns, and that is a square matrix. Kyle, excuse me, the fifth type of matrix. Tell us what it is and define it.
The fifth type of matrix is the diagonal matrix. This is a square matrix in which all elements are 0 except the diagonal elements.
Okay, all elements are 0 except the diagonal elements, and I hope you know what that is. It was explained to you. All right, the last type of matrix is a unit matrix. Kiapin, tell us what that is.
This is a diagonal matrix in which the diagonal elements equal 1.
Okay, it's a diagonal matrix in which all the diagonal elements are equal to 1. Okay, good. So those are the 6 types of matrices that we looked at in our last lesson. Okay, today we'll be looking at adding and subtracting matrices. So the addition and subtraction of matrices. 2 matrices may be added or subtracted provided they are of the same order. Addition is done by adding together the corresponding elements of each of the 2 matrices. Okay, as an example given, 3, 5, 6, and 2 added to 4, 7, 8, 1. Okay, if you look on the screen here, you have to add, because they are in the same position, you have to add 3 to 4, which you get here, and that's 7. Then 5 plus 7, which is 12. 6 plus 8, which is 14. And 2 plus 1, which is 3. Okay, so this is the answer to 3, 5, 6, 2 added to 4, 7, 8, 1. Okay, subtraction is done the same way, except that instead of instead of adding you, subtract. Okay, clear? That's simple. Multiplication of matrices. The first type is called scalar multiplication. where a matrix may be multiplied by a number as follows. So have a look at the screen. You've got 3 multiplied by the matrix 2, 1, 6, 8. That's equal to 3 times 2, 3 times 1, 3 times, okay, this should be 3 times 6, not 6 times 6. Mistake there. And then 3 times 4. Okay, I've got the correct answer here, which is supposed to be 4, 6 times 3. So we get 6, 3 times 2 is 6, 3 times 1 is 3, 6 times 3 is 18, and 4 times 3 is 12. So this is the answer to 3 multiplied by this matrix. Clear? It's very simple. Okay, next one is called general matrix multiplication. It says 2 matrices can only be multiplied together if the number of columns in one is equal to the number of rows in the other. The multiplication is done by multiplying a row by a column as shown below. Okay, that's the matrix 2, 3, 4, 5 multiplied by 5, 2, 3, 6. Okay, note how multiplication is done. You multiply 2 by 5. Okay, and then this one is 4 by 5 here. Then you add it on to 3 times 3, and then 5 times 3. Okay, here. So 2 times 5 is 10. 10 plus 9 is 19. Here. Okay, take note of how it's done. This one, 4 times 5 is 20, and 5 times 3, that's this, 5 times 3 is 15. 20 plus 15 will give 35. So we've used this 2 and 4 and 5 and 3. Okay, then this is now 2 times 2 here, and then 3 times 6 here. Okay, next one is 4 times 2 here, and then 5 times 6. Okay, 2 times 2, that's 2 times 2 is 4. 4 plus 18 is 22. Okay, then 4 times 2 is 8. 5 times 6 is 30. 8 plus 30 is 38. So this is the answer when you multiply these 2 matrices. Okay, take note of how it's done. Okay, example number 2. I've got 3, 4, 5, 6 multiplied by 6, 7. So this matrix multiplied by this. Note that this one, what do we call this matrix here? Column matrix, because it has only one column. Okay, so 3 times 6, 4 times 7, and then 2 times 6, and then 5 times 7. Okay, so it's this way multiplied by, 3 times 6 and then 2 times 6 here. Take note. And we get 4 times 7 here and 5 times 7. So we get 18 plus 28 will give us 46, and 12 plus 35 will give 47. You end up with one column matrix. Clear? Okay, it's very easy. You are going to do an exercise before that I'll explain a little bit more. Usually, we use letters of the alphabet, and it's usually capital letters that I use to denote or represent matrices like I've got here on the screen. There's matrix A is 3, 1, 7, 4, and matrix B is 2, 3. All right, generally speaking, matrix products are non-commutative, which means that A multiplied by B is not equal to B multiplied by A because they are different matrices. And remember, because of the way we multiply, they cannot be equal. Clear? Because you multiply according to the position that they have on the matrix. So AB in algebra would be equal to BA, but in this case they are not equal. Okay, if A is of the order 4 times 3 and B is of the order 3 times 2, then AB is of the order 4 times 4. Remember what the order is? When I say A is of the order 4 times 3, what do I mean? 4 rows and 3 columns, or 4 columns and 3 rows? What comes first? Rows and columns. So don't forget. So that means it's 4 rows and 3 columns, or 3 rows and 2 columns. And then it says AB will be of the order 4 times 2, 4 by 2. Remember, 4 is the row. Is it row or column of the first one, of A? Row, and 2 is the column of the second one. So the result is going to be 4 by 2. Please take note. Just look at this one. This is a 2 by 2 matrix. This is a column matrix. Okay, we end up with this, which is a column matrix. Okay, take note, it's a bit like that. So there's a very short exercise here that you can actually complete before the bell goes. Number 1, it says form C equals A plus B, which means you are going to get C by adding matrix A to matrix B. So exercise 1, number 1. And when you finish that, I'll give you number 2. Hmm? Which one? Are you going to? Oh, like the first one that you did, like Mr. Multiplication one, like that? Yeah. But then you get the answer to P and Q and then you multiply it by. I didn't give an example on this one. Yeah, no, it doesn't. Just like any. Yep. correct. Finished? Okay, any volunteer to come and do number 1 on the board? We. Number 2. Anyone for number 2? Megan. Number 3. Taumaku, okay. Come, you first. You're gonna have to really remember it, you know. And I'm saying, you're gonna have to really remember it. Later we are going to learn to solve simultaneous equations using matrices. It's very easy. You just look at the coefficient of the... Correct? Is this one correct? 6, 7, 8, 3. Yes. Okay, number 2. Good, 28, 14, 17, and 11. That's for number 2. Number 3. Do it on the right. On your right. Right there. It's supposed to be. In the other book, it actually has that type of brackets. In the blue book. In the blue book, it uses those types. I'll have to check another book to actually confirm. Where? Oh, it's a film. Ah, what is it about?
Another one, like this input at the back of the head.
Oh.
People along, something to the computer work. And then they fight inside the computer.
Ah.
And there are lots of numbers.
Is that why it's called Matrix? Interesting. Is it a science fiction? I don't like watching science fiction for some reason.
When they fight, it's like slow motion. They can stop bullets with that.
Hmm.
You can fight with a machine gun. You can sit like that. All the bullets stop. When you drop it, all the bullets break down. Computer power.
Mm. These computer chips here. Well done, Danielle. Or did you just change your name? Okay. One more before you go. One more. I'm just wondering if I'm breaking a rule. I can't add. To add, you only, it has to be the same order. I almost broke the rule. Two by three, 3 by 2. That one is 2 by 3, 2 by 2. 2 by 3, yeah, that one is 3 by 2. Huh? 3 by 2 and 2 by 2. It's supposed to be 2 by 3, 3 by 2. Okay, one more. You can multiply like this. It's good, yeah. It should have been 3. 2 by 3 and 3 by 2. Anyone finished that one yet? Yes? We need one more person to complete it so we can compare the answer. Any others finished? Okay, Siegfried, you give us the answer to the one on the board and we'll see if, Lester, you finished too? Okay, we'll see if your answers are the same as Lester's. We need one or two people to check. You just give us the answer.
By column 16, 18, 13, sorry, first column is 16, 18.
16, 18, like this. Oh, 18.
Okay, second column 13, 19.
Okay. And then? You didn't do this one. Okay, Daniel. Quick.
28, 13, column. 28, 13.
98 or 28? 28, 13.
Remove 20 and 30. No.
20 and 30. Okay.
28,
28,
13, 29, 23.
29, 23. Or 39. I thought he said 29. Okay, so 28, 13, 39, 23. So you all agree now? Okay. For homework, you are going to do only one question, and that's question 4 on the screen. It's a much easier one. If m is equal to p minus q, then p and q are given. Find m. Okay, we have to finish first. The keyword to the pilot teacher is operations. Good afternoon, class. Thank you.